Everyone. Now I am with my sixth lecture series continuation of seismic data acquisition, data interpretation. So in my last lecture, I have already discussed you about the fold faults and little bit concept of the geology as part of the seismic lecture. So in this lecture, I'll be telling about the multi-channel seismic survey, and that is specially done by Geological Survey of India Marine Division from the state of the art equipment or vessel RV Samudra Ratnakar. So more than the theory, this lecture is all about some practical onboard data acquisition, some glimpse of marine multi-channel seismic analysis about the equipment, what are there in the sophisticated the state of art equipments. Okay, so these are all the mm, this is the gun system, this is the seismic ocean may how to take the data, and this is the streamer system. To my first lecture, I mean about the RV Samudra Ratnakar state of the art equipment. So what are the equipments there in RV Samudra Ratnakar? There is a multi-channel seismic system, there is a marine gravimeter, also magnetometer, there is also sub-bottom profiler, channel echo sounder means how to delineate the, I mean these are all equipments to know the subsurface, and this sub bottom profile is very high shallow resolution shallow seismic equipment. So for geological part, there is a piston corer, vibro corer, spade corer. This is all the geological equipments. Remote of ROV, the conductivity, temperature and density measurement, heat flow measurement. So very sophisticated ship, that is GSI is just having marine division, and name is RV Samudra Ratnakar. So in this lecture, we will be specially talking about the multi-channel seismic system equipments in this onboard. So take this is one of the backside view of the RV Samudra Ratnakar. So these are the streamer system. These are all equipments to be used for streamer that I'll be talking in this lecture. And there's a very nice view of the ocean, and all equipments are there. So for the deployment of streamer, you have to access this section and for deployment. Like this is the this is the streamer deployment, and this is the seismic air gun array. This is the source of the seismic. The source I have already described about what is generally seismic sources and how generally they are operated. And there are four gun systems. So the hydrophones, what is generally in short hydrophone? This is electroacoustic transducer which convert the pressure pulse into the voltage, and which is by the piezoelectric crystal. So this helps you to provide better signal to noise ratio. When there are much more hydrophones, they are generally in a coherence and summed in series, so to have better S/N ratio and to improve their voltage output. So this tailboy name is generally associated with the streamer, the backside portion of the streamer, which provide a reference on the cable position. So it is there to ensure whether the cable has straightened out or not. Also, it may help indicate the drifting of the cable or feathering. So most importantly, a GPS is fixed on the tailboy, asserting the position of the tail end of the cable. So the tail end of the cable, that's why its name is tailboy. It also helps in retrieving the cable if in an emergency the cable is cut or any position, unwanted position. Okay. So most important, one of the important parts is high pressure air gun. So it stores compressed air and it releases through the sports when the firing command is released. So the ports generally are opened by an external movable piece called a sleeve or an internal movable piece called a shuttle. Generally, when air gun fires, the energy contained in the compressed air, that is converted into a sound, and it generates a seismic signal that travels into the earth. It ranges from 30 to 800 cubic inch, the volume of the air reservoir. So it is a very sophisticated air gun. Mechanism is not so simple as it looks like. Many hurdles are there to operate. So there is another thing that is associated with the hydrophone of the streamer. It is called streamer recovery device that I have showed in my one of the slides. What are there in the back deck? So it is generally installed at regular intervals along the streamer, that is along 300 meter. Generally, streamer is 6 kilometers long. If the steamer is severed or become detached from the tow vessel or sinks, it automatically activates at 30 to 35 meters of seawater, and it releases the compressed carbon dioxide into the flotation bag. So that's in that way it inflates, and the buoy floats the streamer to the surface for recovery. So it is generally for the recovery of the streamer. That's why it's called streamer recovery device. In the floating bag, the compressed CO2, and this is that at in 300-meter interval generally it is installed. This is called the streamer recovery and streamer bird. This looks like a bird, so it is called the bird. So now talking about the air gun arrays. When we use air gun, the single gun is not used. There are generally 3 to 4 strings of array guns is generally deployed to have better S by N ratio. So and they are generally fired simultaneously. And what is the signature of the air gun? So in my many slides in this seismic total lecture series, I've talked about the seismic signature of the wavelets. So the signature of the air gun is the from far from the ideal seismic wavelet. We generally doesn't know the signature of the source. Generally, the direct arrival from the guns are generally summed coherently, and sounds from the bubble pass that adds incoherently. So the different chamber size produce different bubble responses, and thereby attenuating them relating to the direct interval. So generally this is from the single air gun and with a peak pressure of 4.6 bar meter, and this is the 7 air gun arrays. So look at the difference. Here the secondary bubble pulses are not suppressed, but in this figure whenever we are using a several gun arrays, so there is a suppression of the bubble pulses. So this is more acceptable. We are using there 7 gun array, one of the typical example, 1222 meter cube volume, and this is a single air gun system. Generally that signature of the air gun is not actually the ideal seismic wavelet, and the dominant frequency of the pulse depend generally on the energy, this dominant frequency. So we use a mixture of air gun to have broader frequency spectrum. So generally this is acceptable for us. So whenever we are calling this a air gun arrays, so our ideal picture will be like this, where the bubble pulses are suppressed. It is called a source signature. Whenever the bubble pulse is formed, and it provides the pulse of the energy. So but and when the bubble pulse form, it expands until the pressure inside is less than the hydrostatic pressure of the water head adjacent to it. Then the bubble begin to collapse and is compressed by the hydrostatic pressure, reaches to the same level as the pressure created at the initial level. So the oscillating bubble slowly rises up to the water, and we are having a sequence of pulses. A primary pulse, and there is a bubble pulse, where the primary pulse is dominant, and there is a bubble pulse is effectively suppressed. So the shape of the pressure signal, which is created by the air gun, is called the signature. So it's theoretically it's called air gun signature and the bubble effect. So wherever we are having that streamer recording system, generally this is called the seismic recording system, very sophisticated instrument within onboard, and there's a seismic the streamer telemetry interface chassis. It this system functions in conjunction with the digistreamer electronic module, and to provide a superior collection of data in excess of the 20 streamers or 19,200 channels with an IQ frequency of 250 Hz. So what are the generally in our onboard ship what we use as a data acquisition parameter? So 4 air gun volume, 4 strings with 3000 cubic inch pressure, and maximum is a 6000. Pressure is 2000 psi. Primary to bubbles ratio is 14.9 divided by 3. Hydrophone array that is 6 kilometer long or 6000 meter. Generally 25 to 50 meter the short interval is used, which is controlled by Orca, and it's also navigation system. The receiver interval, what are the receiver to receive the energy? 12.5 meter. Near offset means the source air gun to the first receiver distance is 60 to 70 meter, and if it's a hydrophone is 6 kilometer long, so the far offset will be 6,000 positive 6,000 adding 60 or 70, 6,060 to 6,070. So the record length means up to which length we are measuring up to the subsurface, that is 10 to 15 second. That's called, it's called deep seismic. Sampling interval is 1 to 2 millisecond. If it's a 1 millisecond, then Nyquist frequency is 250, 500, and it's a 2, it's set 250 hertz. So there are 480 number of channels in our onboard, and it's a streamer that's called multi-channel seismic system. And this parameter is associated with the data SB2, to have better resolution of the data. It's called CDP. Higher the number of CDP, the better resolution. So that's called receiver interval into number of channels by divided by 2 into source interval. That is generally 60/30. That is called CDP fold. So let's have now we came to our one of the typical example that we got from the section, that is the two-way travel time TWT, and in vertic, and this is a horizontally, that is called one CDP, or the longitude how you measure it. So this is called direct arrival from the source. This is the sea bottom reflection, this is the reflection hyperbola. So at a double time we got 2.5, that will be some 2.7, 5.4, so that will be sea bottom multiple. You can easily visualize it. So in my last and fourth lecture, shallow seismic equation, I have demonstrated this some typical example of shallow seismic equation. So this is nothing but a deep seismic equation where the TWT time will be more, that is more will be the depth, and some there is a noise that is called swell noise. So we have to get rid of all the swell noise, direct arrival, attenuate the multiples. Then we, our primary objective is to only get the sea bottom reflection, reflection phenomena. So now you can easily visualize, this is the velocity analysis where you are having many semblance, for which the theory of which already described in my previous, we have to follow my previous slides for what is semblance, what is CMP, what is the dynamic stack, and how there is a gathering of semblance. And you have to analyze the proper velocity or the interval velocity from this or the primary event. So the typical time, what is the velocity, what is the interval velocity, we'll get it through a software. So as part of the field example on onboard acquisition, here are two sections, that is the GSI report on multi seismic survey that are acquired of Bay of Bengal. One is cruise 26 and one is field season 44. Some practical seismic section where there is a demonstration of some geological parameter, that means that is of 90 east reach, 90-degree longitude, and there is some host gravel structure, there is a trench axis, and there is a particular geological terms called accretionary prism where we're having uh, very uneven surfaces where there is a hardly any ray can penetrate, and there is a very tough zone to have seismic analysis. So below this, it's there are some geological provinces are there, that is 90 reach. There is a trench in Andaman. It occurred in the Andaman Bay, trench basin, and there is also a accretionary prism. So you can see there is a many crests and troughs there in the accretionary prism, and fold and fault. In my last lecture as a fold and fault, I have shown you this picture how the anticline and syncline fold, what are their characteristics. Now this is one of the reference from which I was also a participant of the cruise, where we have, this is on GSI report on the tectonic setup of Bay of Bengal and Andaman Nicobar subduction complex by the multi-channel seismic survey through RV Samudra Ratnakar. So you can see there is some uh, mm, undulating structures are there, faults, oceanic crust, and this is a mm, sedimentary region, and these are faults in the oceanic crust, these are bent faulting, and some flower type structures are there. This is the basaltic flow. Basaltic flow means this is a hard, very hard, and where the velocity of seismic ray will be much more. So now you can see different geological provinces, and which is particularly in the 90s reach how the faults are being marked. Same, and this the same cruise. I mean, this is the different geological provinces. This is Bengal fan, this is a 90s reach, there is Andaman Trench Basin, and there is accretionary prism. And most probably these are all the sedimentary units, sedimentary horizon, which are exaggerated in this figure. So there are four units, one, two, three, and four. And this is the top of the oceanic crust, the green region. So this within the accretionary prism, I've already told about the different formation of anticline and the syncline fold. It's a particular one cruise with the line number L2, along one line. So there are the marking of paleo channels, the subsidence zones, bed faulting, basement faults, decollement, pelagic sediments is there. See, these are all some geological terms which has to be, I mean, shown after the full seismic data analysis. What are the geology of the marine subsurface? I mean, oceanic. So very complex region. In Andaman region, it's a very complex. So you have to carefully analyze it. And what are the sedimentary units that are also written there. So these are the legends. So you can see through which legend up to which depth analyze. So this is almost 3 kilometers of the depth, the sea bottom, and it's varying the sea. And you can see the most rugged terrain sea bottom can be reflected in this zone that is called accretionary prism. Within the trench basin zone, there is some sedimentary units, and it's very almost very smooth. And in the left side also, that Bengal fan and 90 stretch, the rugged terrain portion is little bit more compared to the trench basin. So in the trench basin part, the depth is also very prominent. So from sea bottom, that depth is 2.8 kilometer, means that is also 3 kilometer 2.8. So total penetration of seismic ray is almost 6 kilometer up to that, and here that is 3 kilometer plus 4 kilometers, so 7.5 kilometer along the trench axis. So it is the deepest portion that the seismic but through multi-channel seismic channel has deciphered in this region. So these are all, and these are the sedimentary units. Now, talking about our field study, I mean, field study of case study in the Andaman Sea, in the Arabian Sea or the west coast of India. So this is the any uninterpreted seismic section. So from each section is from west to eastern part, and this is CDP through which we analyze, and these are taken along the Lakshadweep Bridge with the integrated multi-channel survey. When we talk about its the interpreted section compared, I mean, through uninterpreted section, you can interpret it in this way. So along the western part, that is the abyssal plain. So this is a deepest plain. So in the west coast, the depth generally increases to the western part, and when you go to the eastern part, that is the West Lakshadweep slope, there is a flood basalt where the seismic wave velocity is much more basaltic portion. So there is a seafloor is also some rock terrain is also there. So this is a rich portion from here to here, that is completely Lakshadweep ridge. This the combination of these local ridges, and this trap portion you can see easily is a trap. This is called and the Lakshadweep basin traps. The horizontal extent is almost 80 kilometer, you can see. So and when you go in the along the coast part, you'll get continental slope and the continental shelf. It is there in the marine slope. And what are the geological features? You can see it's a Pratap ridge, there's a Lakshadweep ridge. And when we are exaggerating, I mean, this figure, zooming this figure, you can see here in the abyssal plain there's an intrusive life figure, and this is there is a subsidence. Okay, and when we uh, zoom in this figure West Lakshadweep slope, we can see there is a evidence of mass transfer deposit within this zone. So carefully, and within that eastern zone, the sedimentary part along the Pratap ridge, different seismic horizons are reflected here, revealed here. So, and their nature, what are the sedimentary nature along in the Pratap Ridge? There is adjacent to it is a terrigenous material and the volcanoclastic material. So this is one of the our field study acquired of Arabian Sea region with integrated multi-channel seismic gravity and magnetic survey, and these are all its participants. Now our last case study will be on also the multi-channel seismic survey of offshore of Bay of Bengal, Andaman Sea. So you need, already I have told Andaman Sea is a very complex region which has to be meticulously described, and there is a much more to reveal. Uh, so you can see there is also this is a multi-beam bathymetric survey, and this red color means lower depth and is there any uplifted portion of the I mean subsurface below sea bottom. This the starting from the western part. This is a coast near to the coast. This is a West Andaman fault. Thereafter, there is a small sack-filled valley, and we can see West Seawell Ridge. There's a volcanic arc portion. Thereafter, there is some say sedimentary sequence portion. Followed by this, there is a Seawell Rise portion, and in the eastern part, we're having East Basin, or that is called the rifting extensional zone. So I think before following this lecture, you should obviously follow my last lecture of fault and conformity on the geology, on little bit knowledge of geology. So our one of our objective is also to have thickness of the sediment in this eastern basin part. So you can see there is a west seaward rise portion. There is also some red part means the uplifted position, and where there is a gravity data. There's a free air gravity anomaly is exactly mimicking the topography. It's a very high portion. So where there is some crest or trap portion, accordingly the FA gravity anomaly is increasing or decreasing. So there is a uplifted portion on the sinusoidal wave, the gravity anomaly is high. Here also west seawell ridge, and in the geological portion it's high. And magnetic data is not following any kinds of this topographical uh, I mean following thing. But in the volcanic arc you can see the obviously the gravity anomaly is high, and there is a multi-beam swath bathymetry that is collaborating with the our seismic section. And there's a faults and folds, some isolated ridges, valleys, intrusive, and the basements that are in the eastern basin part. There's a syndrift type delta deposit, the west extension syndrift, and the continental crust percent higher depth that are being revealed in this uh, seismic section. So this another in the that is in the same region, but the line number is different. So you can see the geology from western to eastern part is the same. The only the same means like East Andaman Basin, Swell Ridge, Central Andaman Basin, Volcanic Arc, and the Four Arc Basin. These are same. So you can see the free air gravity anomaly is high on the Volcanic Arc, and it is in the Swell Rise. So within the magmatic arc there's a within the trap position there's a water depth is very high. This is a longitudinal trap position, the higher water depth. And in the eastern basin portion also water depth is high, and within that and in the east seawell ridge there is some uplifted portions. So western seawell rise also there's uplifted portion. So in the eastern basin part there's a too much geological complex figures are shown here with the nature, characteristics, and the types of sediment. So hope you have glimpse of how the practical field study, case study, example or the acquisition in the ship are being taken out. It's a very, I mean, it's very, told in a very short way, and real practical example is very tough to acquire data. So this is also a our multi-channel seismic survey of Andaman Sea for the tectonic setup of back spreading center in soil within the economic exclusive economic zone of India. Okay, and here you can we have also delineated some sedimentary units and the characteristics of the sedimentary unit means what are the late Miocene or Pleistocene, middle Miocene, early Miocene, Oligocene, how these units are varying according to the depth, and what is the velocity of the seismic ray within that unit, the velocity analysis. Thank you all. I think you must have seen some practical case study example and onboard ship study, how they are generally carried out. So this was my last lecture of hopefully the of seismic with geology with onboard ship, the deep and the shallow seismic study. So this is my lecture physics and geophysics learning. And if you have liked it, please share, follow, comment, and like and turn on bell notification icon for subscription to have the latest update. Thank you all.